So today what we're going to talk about a linear function. Before we start everything, we need to understand the behavior of a linear function and how it operates. So let's talk about the behavior. Under behavior, the two things that you need to look at, you need to know the mother graph, which is the basic graph, which is known as y is equals to x. Then we have something called what? The standard graph. And that is what? Y is equals to ax plus q. To know the behavior of the graph, the first thing that we need to look at the effect of A and the effect of Q. So now what we're going to do is we're going to look at the mother graph, which as I said is y is equals to x. And that's the red one. Do you see the fact that it's just a straight line going from what? The first quadrant to the third quadrant. So this is the basic graph. So now what we're going to do is we're going to discuss the effect of A. We know that A can either be positive or negative. That's the two effects of A. So now, for instance, let's say A is equals to positive 2. Let's see what happens to the graph when A is equals to positive 2. So let's say y is equals to what? To 2x. Do you see what happens? Is the graph still goes from the first quadrant to the second quadrant when A is positive and becomes a little bit steeper. But the steepness of the graph is really not important now. Now you just need to understand how the graph, which quadrant the graph is going to be in. And we see the fact that the graph is going to be where? In the first and third quadrant. Now, let's make what? Our A equals to negative 2. So let's go there. So now let's say y is equals to what? To negative 2x. Do you see what happens? What happens is it's the Greek graph, right? The graph changes the quadrant that it existed in. Now the graph moves from what? It moves from the second to the fourth quadrant. So another remark that you need to know about this is that when A is positive, the graph is increasing. When A is what is negative, the graph is decreasing. So now let's talk about the effect of A. So we know that when A is greater than 0, meaning that A is positive, what happens? The graph is going to be increasing, and also it's in the first and third quadrant. So now let's talk about when A is what is negative. So now when A is less than 0, meaning A is negative, what's going to happen? The graph is going to be decreasing, and it's going to be where? In the second and fourth quadrant. So now what we're going to talk about the effect of Q and how the graph operates when Q is involved. So now we're going to take the basic graph or the mother graph, and what I'm going to do is I'm going to add a Q. I'm going to add a positive Q, and I'm going to add a negative Q. So the first time, let's say Q is equals to what? It's equals to 1. And let's see how the graph behaves. If we say y is equals to x plus 1, do you see it's the purple graph? From the red graph, let's investigate how the graph operates, right? Is that this is the red graph. When Q is plus 1, it moves 1 unit up, right? So it moves whatever Q value is upwards when it's positive. Now, let's say our Q is negative 1. Let's see what happens to the graph. So if we say y is equals to x minus 1, do you see it's the black one? When it's negative 1, the graph is going to move downwards by whatever Q unit, in our case is 1 unit, right? So to conclude this is that Q moves the graph up and down. So now looking at the effect of Q, the first part is that when Q is what? When Q is greater than 0, meaning that Q is positive, what happens? The graph moves Q units up. And the second one is when Q is negative. When Q is less than 0, meaning it's negative, what happens to the graph? The graph moves Q units down. And that's the behavior of the graph. So now I want to move to the next section, which is domain and range. What's domain and what's range? Domain. First, let me define it. Domain is all the x values in the graph. That's our domain. And what's range? Range is all the y values in the graph. So now, just looking specifically at our linear function, what's going to be our domain and what's going to be our range? I'm going to write it here in yellow. This is a case of always. Our domain, when they ask you in a test what's domain, when you're dealing with domain and range, you know the fact that domain is going to be what? It's going to be x is an element of real numbers, right? This is a case of always. And if they ask you what's the range, you're going to say y is an element of real numbers. Now let's talk about intercepts, right? We have x-intercepts and we have y-intercepts. Let me show you what is the x-intercepts and the y-intercepts on the graph first before we learn how to solve it. So now, looking at our purple graph, I'm going to show you on the graph what is the x-intercept and what is the y-intercept, right? So this is called what? Our y-axis. And this one, it's called our x-axis. So the one that goes what? Vertically down is called what? Our y-axis. And the one that goes horizontally is called our x-axis, right? So do you see this point? The one that I just made black, right? That is called what? It's going to be called our y-intercept because it cuts through what? It cuts through our y-axis, right? Then this one, the one that that's -1 and 0. That's going to be called our x-intercept. The reason why is because of it cuts through the y-axis. So that's our x-intercept and our y-intercept, right? And look at something. You see the fact that when we talk about the y-intercept, the x is always 0. And when we talk about the x-intercept, the y is always 0. You'll see why is that. So now let me show you how to solve for your x and y intercept. So now what we're going to do is we're going to try to solve the x-intercept and the y-intercept, right? So I'm going to take the purple graph that I just drew and I'm going to use that to solve our x and y intercept. So we know that our function is y is equals to x plus 1. And on this function, what we're going to do is we're going to look for our x-intercept and our y-intercept. So now let me start with my x-intercept. So the x-intercepts. When solving x-intercept, we need to let y equals to 0. This is a case of always. So if we're going to let y equals to 0, what we need to do is from the function, wherever we see y, we need to substitute 0. So this is our function. It starts with y. So wherever we see y, we substitute 0. So you're going to say 0 is equals to x plus 1. Then what you're going to do is you're going to make x subject of the formula. So you're going to take this positive 1 to the other side so x can be alone. So when we do that, since it's positive, when we take it to the other side, it's going to become negative. So it's going to be -1 is equals to x, right? Then we're going to write this in a coordinate form, meaning we know that our x is going to be equals to 1. So here it's going to be equals to 1. It's going to be equals to -1. And since we let our y equals to 0, that's going to be our y coordinate. So it's going to be 0. So this will be your x-intercepts coordinate. So now moving on to finding the y-intercepts. With the y-intercept, what you need to do is you always need to let what x equals to 0. So meaning that wherever you see x, you're going to substitute 0, right? So let's do that. We know the fact that our function is y is equals to x plus 1. So this is our x. Wherever we see x, we're going to substitute 0. So you're going to say y is equals to what? 0 plus 1. Then 0 plus 1, it's going to give you what? Y is going to be equals to 1. Then now we're going to write it in coordinate form. In coordinate form, we know the fact that we let x equals to 0. So our x is going to be 0. Then our y is going to be 1. And that's going to be your two intercepts. So your two intercepts are going to be -1 and 0 and 1 and 0. As you see from the graph, that's what we had. So this is how you find your x and y intercepts. So now what we're going to talk about, we're going to talk about sketching. With sketching, there's a few things that you need to know in order to sketch successfully a linear graph. So the first one is what? is the sign of A, right? With the sign of A is going to tell you, as we discussed previously when we were looking at characteristics or the behavior, is that A is going to tell you whether the graph is going to be in the first or third quadrant, or A is going it's going to tell you whether it's going to be in the second or fourth quadrant. A tells you where the graph is going to be situated in. And the second part that we need to know is the intercepts. So we need to calculate the x and y intercepts. So now let's say we have an example of y is equals to 2x plus 9. And they say sketch this graph. With sketching, we need to follow the rules that I told you. One, you need to determine the sign of A so that you can know where your graph lies. And two, we need to find the intercepts. So let's do the first part. I'm going to do it in red. So the first part is the sign of A. We know that A is equals to 2. If A is equals to 2, meaning that our graph is going to lie where? It's going to lie in the first and third quadrant, right? Now, let's look at for number 2. Let's look at for the intercepts. With our intercept, we need to find the x-intercepts and the y-intercepts. So now we're going to calculate the x-intercepts. With the x-intercept, we know the fact that we need to let what? We need to let y equals to 0. So wherever we see y, we're going to substitute 0. So let's do that. So we're going to say 0 is equals to 2x plus 9, right? So now what we need to do, we need to solve for x. So we need to make x subject of the formula. First, we're going to take the 9 to the other side. So it's going to be negative 9. It's equals to 2x. Now we need to make sure that x is alone. So we're going to divide both sides by 2. So the 2 here is going to cancel out. So what we're going to be left is negative 9 over 2 is equals to x. Writing in coordinate 4. We have our x as being negative 9 over 2. So you're going to say negative 9 over 2. Then we know the fact that our y is 0 because we let y equals to 0. So that's going to be 0 here. So we're done solving our x-intercepts. So now let's solve for our y-intercept. So we're going to say y-intercepts, and we're going to let what? We're going to let x equals to 0. Wherever we see x, we're going to substitute 0 in our formula, right? So let's do that. So we're going to say y is equals to what? 2 open bracket 0 plus 9. 2 multiplied by 0 is going to give you 0. So it's going to be y is equals to 0 plus 9. Therefore, our y is going to be equals to what? It's going to be equals to 9. Now we need to write it in coordinate form. Our x is going to be 0 because we let x equals to 0. So it's going to be 0. And our y is going to be the one that we just solved, which is 9. And that's going to be your y-intercept. So now I clear the screen, then I put all the information that I just calculated, our x-intercept and our y-intercept and the shape, right? So what we're going to do is we're going to label our triangle. You're going to put your arrows like this, not our triangle. So now what we're going to do is we're going to put arrows on our Cartesian plane like this. Then we're going to say this is y and this is x, right? So this one represents the positive y-axis, and this one's going to represent the negative y-axis. This is going to represent the positive x-axis, and this is going to represent our negative x-axis. So what do we have? First, since negative 9 over 2 is what? It's positive, right? Since negative 9 over 2 is a fraction, what we need to do is we need to change it into being what? Into being a decimal. So let's do that. So what you're going to do, you're going to press the negative sign. Then after pressing the negative sign, you're going to go to your division. Then you're going to say 9 divided by 2. We want to change that into a decimal. So you're going to say equals 2. You see the fact that you have it here. Then what you're going to do is you're going to press this. See, when you press the S with the D, this is what you get. So we know the fact that our decimal is going to be what? It's going to be negative 4.5 when we change it into a decimal form. So I've changed it into a decimal, and that's the one I wrote in yellow. So let's say this is going to be our negative 4. This is going to be negative 4 here. And let's say this is negative 5. And what we need is we need a negative 4.5. Negative 4.5 is between negative 5 and negative 4. So this would be our point here. So the y-intercept cuts where? On the y-axis. We know the fact that our y is positive, so it needs to be here. Let's say this is our 9, because we just sketching. So it doesn't really need to be accurate. So then you're going to put a dot here. Then the nice thing about a straight line, you just need to connect the two. So let's do that. So when you connect the two, it's going to just go like this. You would use a ruler, and this would be your graph. So you see the fact that you already can mark yourself. You see already your graph is correct because of first, it mimics the shape that you said A would mimic. So, and also you have your X and Y intercept. So by default, your answer is correct.